Hey there, Seahawks, it's Miss Adams, and in this video, we're going to learn about sampling distributions of a sample mean. Alright, the sampling distribution of the sample mean x bar describes the distribution of values taken by the sample mean x bar in all possible samples of the same size from the same population. How do we calculate the mean and the standard deviation of our sampling distribution? So the mean of the sampling distribution of x bar is equal to x bar, the sample mean. The standard deviation of the sampling distribution of x bar is equal to sigma over the square root of n. So these formulas and facts are true for the sampling distribution of x bar, no matter what the shape is. Okay, and if we don't know x bar, we would say it's equal to mu if we know the population mean. Important facts about the mean and the standard deviation. The sample mean x bar is an unbiased estimator of the population mean mu. The standard deviation of the sampling distribution describes the typical distance between x bar and the population mean mu. The distribution of x bar is less variable for large samples. The formula for the standard deviation of the distribution of x bar requires that the observations are independent. All right, an example of finding the mean and the standard deviation of the sampling distribution. Suppose the true mean number of hair follicles on a human head is 100,000 with a standard deviation of 40,000. The mean number of follicles on the head of 20 randomly selected humans will be computed. Calculate the mean and standard deviation of the sampling distribution of x bar. So the mean is going to be equal to 100,000, the population mean that they told us. And the standard deviation is going to be the population standard deviation divided by the square root of n. So 40,000 divided by the square root of 20, which gives us 8,944 follicles. Interpret the standard deviation. So remember, interpreting standard deviation, we want those two words typically varies. So in simple random samples of size n equals 20, because remember we are taking sampling distributions, the sample mean number of hair follicles typically varies from the population mean of 100,000 follicles by about 8,944 follicles. All right, describing the shape of the sampling distribution of the sample mean. When sampling from a normally distributed population, the sampling distribution of the sample mean is also normally distributed. So if it's coming from a population distribution that is normal, then the sampling distribution is going to be normal. All right. Probabilities involving x bar. The local SPCA, Society for Prevention of Cruelty to Animals, feeds the animals it shelters, but the amount of food needed per day varies. The distribution of weight of dry dog food used per day is approximately normal with a mean of 30 pounds and a standard deviation of 5.1 pounds. Let x equal the sample mean weight of 6 randomly selected days. Describe the shape, center, and variability of the sampling distribution of x bar for sample sizes of 6. All right, so my shape is going to be approximately normal because they said the population distribution is approximately normal. The center would be equal to 30 pounds because they told us that was the center. The variability, I have to account for the sample size of 6, so I need to take my population standard deviation, 5.1, and divide by the square root of my sample size, 6. This gives me 2.08 pounds. Now, find the probability that the mean weight of dry dog food for 46 randomly selected days is greater than 33 pounds. Oops. This is supposed to just say 6 randomly selected days like it has above. So we have a normal distribution with a mean of 30 and a standard deviation of 2.08. 30 is in the center. We're going to go to 33, shade above, greater than, And then I could do a normal CDF. My lower bound would be 33. My upper bound would be 99999. My mean is 30, and my standard deviation is 2.08. That gives us 0.0746. All right, go Seahawks.